Good morning, everybody. Welcome to the BASF Protect Your Profits Fusarium webinar. We're glad to have you joining us here this morning, wherever you are in Canada. My name is Sean Haney, founder of RealAgriculture.com and host of Real Ag Radio. You can hear every day on Rural Radio 147 on Sirius XM at 4:30 Eastern. I'm going to be moderating today's discussion. We got a great one for you. Joining us is Dr. Michael Harding. He's research scientist with Alberta Agriculture and Forestry. Also Bruce McKinnon, who's the technical service specialist with BASF Canada, and Maurice Van Winsberg. He's the owner and operator of Van Farms in southern Manitoba. Okay, so with the range of experts from across Canada we have here today, we're going to tap into a variety of perspectives on how to protect your profits by getting ahead of Fusarium. Ensuring growers have the tools they need to grow cereals that are healthy and highly profitable is a top priority for BASF. But before the proper tools can be put to good use, it's important to understand the challenges your cereal crop is facing. Today we'll be focusing on Fusarium, one of the key disease challenges that gets in the way of successful cereal crop, no matter if you're in Western Canada or Eastern Canada. Our experts will cover topics ranging from specific details of the pathogen to the big picture perspective of Fusarium in Canada. We'll start by looking at the life cycle of the disease. We'll discuss the difficulty of forecasting Fusarium as well as the significance of its impact on cereals. Our experts will touch on scouting and crop rotation and how this all affects the disease. Our grower expert, Maurice, will challenge will share his experience with Fusarium on his farm, including the tips and tricks he used to manage the disease in the past. We'd like to end the webinar today with time to answer your questions. To submit a question, just type it in the chat box below that will appear on the screen at the end of the discussion. We'll have our experts answer them during the Q&A period. Also, for those of you who are certified crop advisors, you'll receive 1 CCA CEU credit for attending this webinar. If you are registered at an earlier date and forgot to provide your CCA number or forgot to include it when you signed in today, be sure to contact the Ag Solutions customer care at 1-877-371-BASF. Before I let our experts take it away, let's look a little closer at Fusarium and its history in Western Canada. The first thing to note is that Fusarium is not a new disease. In fact, it's been in Western Canada since the early 1900s. That said, the disease was kept within Manitoba borders until the 1980s and has only started to spread rapidly across other Western provinces since 2013. While 2017 and 18 saw less impact from Fusarium, the overall increasing trend of the disease calls for a deepened understanding of the pathogen and how we manage it. Our first speaker, Dr. Michael Harding, grew up on a farm near Taber, Alberta, and he worked as a research scientist for 15 years with Alberta Agriculture and Forestry. Having received his PhD in plant pathology from the University of Arizona, his current work focuses on applied research, extension, and surveillance of diseases on row crops as well as horticulture crops. Dr. Harding, I'll let you take the discussion from here.
Okay, thanks very much, Sean. I appreciate the introduction and the opportunity to talk about Fusarium today. I'm going to try to cover 4 broad topics here. The first is what causes Fusarium head blight, and then because I work mainly in Alberta, I'll talk about Alberta's situation. Cover briefly off some losses to Fusarium head blight that have been quantified, and then finish off talking about management tools. So what causes Fusarium head blight? Well, if you look in the center photograph there on the screen, you can see 4 species of Fusarium. What you see is their macroconidia, or the spores produced by the fungi. And you can see that there are more than one species of Fusarium that can cause head blight. And when those spores get up onto the spike, usually during the anthesis period, they can infect individual spikelets and lead to this premature ripening that you see in the head symptom photo on the left. As the disease progresses, the fungus infects the kernel, the developing kernel, and it leads to shrunken, chalky white-colored kernels, which are called Fusarium-damaged kernels. And you can see an example of that in the photograph on the right. So here are a few more examples of symptoms of Fusarium head blight. On the left is a wheat spike, and you can see that one of the spikelets there is prematurely turning yellow, and if you look really close, you might be able to see some salmony pink color peeking out just under the gloom. So these are some characteristic symptoms. Now, the symptoms can only be seen after flowering, after the anthesis period. So usually anywhere from a week to 2 weeks after flowering, you may start to see some of these florets that start to ripen faster than the rest of the head. On the right, we have an example of Fusarium head blight in barley, and you can see the symptoms there a little bit different, sort of a more of a general necrosis, and then in the center, kernels damaged from wheat on the top and barley on the bottom. So the inoculum for initiating the disease really exists in the crop residues, and these can be any of the small grain cereals, or corn is also a good host for Fusarium. Fusarium can actually infect all of the parts of the plant. It can cause root rots, crown rots, and here we're talking today mainly about head blight. So in the crop residue, the fungus produces spore-producing structures. One of them, parathecia, are produced, and they lead to the production of spores that can be forcibly discharged and get up into the wind currents and be aerially dispersed. The second type of spore is produced in a different structure called a sporodochium, and these spores are mainly rain splashed. So the rain splash spores usually kind of lead to epidemics within a field, and the wind dispersed spores can sometimes get up and move from field to field. And in cases where we have a lot of wind, they can actually move great distances, but usually mostly just field to field. When these spores get up onto the spike, especially during anthesis, they'll cause head blight. And when the grain, the harvested grain, is used for seed, Fusarium can also cause seedling blight, and this will lead to stand establishment issues and other problems. So the result of results of Fusarium head blight infection is yield loss, and there have been billions of dollars of losses due to Fusarium head blight in North America since the 1990s. And in the 80s and 90s, the disease became very rapidly established in Manitoba, and in Alberta, we've kind of had the luxury of watching it come at us and learn from the experiences of the folks in Manitoba and Saskatchewan. So let's talk a little bit about the Alberta situation. So there really are three ways that we can evaluate the severity of Fusarium in Alberta, and one is to take the data from the Canadian Grain Commission's Harvest Sample Program. So that's what I'm showing here, and I've got a link to their website at the bottom. On the vertical axis, you see the percent of samples with Fusarium damaged kernels, and on the horizontal axis, years. And on the right side of the chart is 2003, and then as we move from right to left, increasing years up to 2018. So you can see that the situation in Alberta really started to change around 2010, and the number of samples with Fusarium damaged kernels kind of rose steadily up to the worst in 2016, where over 30% of samples. Now that big dip in 2015 and those low numbers in 2017 and 18 show how responsive the disease can be to weather or environment. And so in 2016 or 2015, we had a very dry summer, and similarly with 2017 and 18, the conditions just weren't very good for head blight to develop. So one of the other questions people also ask is, I thought Fusarium head blight was really restricted to southern Alberta. So when we look at the same results from the Grain Commission, but by crop district, we can see that, yes, in the early 2000s, in the 80s, 90s, and 2000s, we really only consistently detected Fusarium graminearum in southern Alberta in crop districts 1 and 2. But you can see that these trends of increasing amounts of FDKs in samples is increasing in every crop district in Alberta. Now, the second way that we have to evaluate the amount of Fusarium, and now I'm going to talk specifically about Fusarium graminearum. So this is data from 2020 Seed Labs that I got from their website, showing the number of samples that they had tested positive for Fusarium graminearum in 2011. You can see it was mainly restricted to the south. So now let's fast forward to 2016, and we can see that the situation is very different. There are many more counties positive, and you can see that there are many counties that are shaded really dark, indicating lots of samples positive. So the third way we have to evaluate Fusarium head blight in Alberta is actively surveying for it. And so let's look at a couple of maps showing survey results for the work done in Alberta. On the left here, you can see the map from the survey done in 2010. And again, Fusarium head blight graminearum specifically was mainly restricted to the southern areas, especially crops grown under irrigation, and a few positives in a couple of other counties, but these were single fields with very low incidence, and when we went back subsequent years, we couldn't find it. Now fast forward to the map on the right. This is the 2016 survey results, so you can see that we're finding Fusarium graminearum in most of the counties where we grow wheat. So this has changed since 2010 from a problem that was mainly a southern Alberta problem to a problem that now we really need to be watching for just about everywhere we grow wheat in the province. So this map shows the points that were positive for Fusarium graminearum in 2016. So rather than just coloring counties red, you can see the individual locations. You can see that there's a focused concentration in southern Alberta. There's also an increasing focused concentration of spots on the east central side of the province, but the spots all over the province are increasing. So why should we care about this? Well, Fusarium head blight can cause yield loss, which is a problem. Those plump kernels that become shrunken due to Fusarium infection are lighter, and so yield is lost. But really, one of the major economic problems is the downgrading that results from Fusarium damaged kernels being present in grain samples. And one of the reasons for downgrading due to FDKs is that there is a pretty linear relationship between Fusarium damaged kernels in a sample and the amount of mycotoxin in a sample. It's not always true, but it's a good rule of thumb. And these mycotoxins can also lead to market acceptability issues. And all of these losses are additive. They're not exclusive. And to add insult to injury, Fusarium head blight is really difficult to control. So there was an economic cost evaluation done in Alberta in 2015. And I'd like to share with you a couple of the findings from that study. The first one is that when 0.25% FDK in a Canadian Western Red Spring sample was evident, the total revenue loss for both yield and downgrade to from a number 1 to a number 2 was $52 per acre. Now, when this is further downgraded to a 3 or to a feed, the economic impact increases to $62 and $65 per acre, respectively. So the big picture take-home from the study was that the cost of Fusarium head blight in Alberta was between $3 million and $9 million a year, depending on how severe the disease was and depending on what the price of grain was. So that's a very significant amount that's already occurring in Alberta due to Fusarium head blight. So let's finish off talking about management. So how are we going to control this? Really, the take-home message that I'd like to, if you don't remember anything else, is that you can't use just one tool and expect to successfully control Fusarium head blight every year. So what are some of the options we have? Well, we're going to talk about some cultural practices, variety selection, seed health, fungicides, and then talk about some risk assessment tools that are new. Now, this isn't necessarily going to cover off every detail of management, but we're going to try to hit the highlights. So with respect to cultural practices, really the primary and I think foundational management tool is to provide a 2 to 3 year break between host crops. So host crops include small grain cereals like wheat, barley, oat, rye, triticale, and corn. And non-hosts would be broadleaf crops, including pulses, oilseeds, and horticultural crops. So providing that 2-year break allows the residues to break down, and then the inoculum really becomes much less. The disease pressure really drops. The second thing we can do is to provide balanced soil fertility, and this allows the crop to get a good, healthy start. And there's also some direct evidence that good soil fertility actually can help prevent head blight directly. Now, it might seem a little counterintuitive as to why scouting crops regularly for Fusarium head blight symptoms is a cultural practice, or why I'm putting it here. We're going to talk about it in a subsequent slide, but I wanted to put it in here because this is something that if you do it yourself, it doesn't cost you anything other than your time, and it can really help you to evaluate how effective your management strategies are and how much of a problem you have on your farm. So carefully handling infested grain and straw is also a cultural practice. And this is to avoid spreading it around to fields where it's not established. So if the disease is already really well established on all of your farm unit, this is less of an issue. But if you're in an area where you don't commonly see head blight, it's important to keep it out. Silage of crops can be an effective way to remove a lot of the infected tissues. Chopping straw to smaller pieces can help it decompose quicker. Turning under crop residues, this is a much larger discussion that we don't have time for today. There's lots of really good reasons to practice zero-till or minimum till or conservation tillage. But one of the caveats we have to accept when we leave more residue is that we're going to have more residue-borne disease inoculum. And then finally, avoiding irrigation during flowering, because higher humidity can increase the risk of the disease getting started. Sometimes we can avoid the disease. Winter wheat, there are some resistant cultivars, and sometimes the flowering period is early enough that we avoid the disease. So let's talk now about variety selection. In each province, you'll have variety guides or the seed guides, etc. It's important, if Fusarium is becoming a threat to your farm, to look for those varieties that fit well in your operation, but also have that moderately resistant rating for Fusarium head blight. If you're growing Amber Durum, unfortunately, we don't have any real resistance in that market class, but we now have many more options for resistance than we did 10 years ago. With respect to seed health, we don't want to bring Fusarium to a field that it hasn't been established in, so having your seed tested and found to be free of Fusarium graminearum is an important way to keep it out. And then if there is some Fusarium on the seed, treating it with a seed treatment that has Fusarium on the label can help prevent stand establishment issues, as long as the amount of infection isn't going to overwhelm the treatment. Okay, fungicides. So we can get some chemical control of Fusarium head blight using fungicides, but it's important to note that the window of application is really tough to hit, and that these fungicides provide suppression only. So this is why I think it's important to recognize that while chemical control is a really important management tool, it may not get you all the way there if it's the only tool that you use. It's also important to follow label directions to make sure that you get it right. So some of the fungicides that are registered for suppression of Fusarium head blight, you're going to hear more about later, but if you want to get detailed information, you can talk to your trusted advisor or retail agronomist, or you can check your province's crop protection guidebook. Wanted to touch briefly on sprayer technology and nozzles. This is an important part because the head stands a lot of times vertically. It's a little more difficult of a target to hit than the leaves, which kind of present more of a horizontal target. There's been a lot of work done on this, and I provided a link to Sprayers 101 if you want to know more about this. But basically, there are certain types of nozzles that work best. You want, and I apologize for this, you want coarse droplets. The nozzle should be angled. You want to make sure you put enough water on, and you want your boom height at the right height. And you'll hear more about this later today. So finally, are there any new tools available to help us manage Fusarium head blight? And in Alberta, the answer is yes. We now have a risk prediction tool that allows us to evaluate the risk of Fusarium. So the tool is located, if you go to Alberta Climate Information Service, which I've indicated the link there, but if you just Google ACIS, you should get the Alberta Climate Information Service website. Once you're at their site, on the left side of the screen, you'll scroll down and see on the taskbar a Fusarium disease severity. And if you click on that, you'll get some information shown on the next slide. So the panel on the left shows a view that kind of has a dashboard. You can see there number 10 with a half circle there that's colored partially yellow. So this would be indicating the Fusarium risk at the weather station nearest to your location. And you can choose the weather station that you'd like to see the information for. And then it will show you all of the information, the relevant information for Fusarium head blight that weather station has collected, including temperature, rainfall, and then it will show you the Fusarium risk. And that's the black line that you see there that starts high, dips down. So you can get a view like that. The second view you can get is on the right side of the right panel, and this is a map view where you can see all of the weather stations, say in a region, and there's a little dial there, a speedometer, indicating whether the risk is low or high. And so you can get an idea of what the situation in a region is. So to summarize what I've covered today, Fusarium head blight is a disease of concern in wheat, barley, and corn. It's caused by a number of species, but most especially Fusarium graminearum is definitely the most aggressive head pathogen. Fusarium graminearum has now spread to most of the cereal producing areas of Alberta, and it is a serious economic concern, causing losses in Alberta. There are, however, a number of beneficial practices for managing Fusarium head blight. And while no single tool will control Fusarium head blight, my recommendation is that you arm yourself with information. If you understand the pathogen and how the disease works, deploy resistant cultivars, use clean disease-free seed with a seed treatment, beneficial cultural practices and good agronomy, and then estimate the risk in season using the tools available, and then a timely application at anthesis if needed. You'll most years probably be able to stay ahead of Fusarium head blight. One thing I really would recommend, especially where Fusarium is kind of becoming an issue, for those that haven't had it for a long time.
Technical Service Specialist with BASF. He'll be sharing his insight on the consequences of Fusarium on cereal crops and the knowledge BASF has gained to best manage this terrible disease. Bruce, you're up.
Thanks, Sean. Good morning, everybody. Thanks, Mike. That was a good overview and some great information. I'm going to cover a little bit, kind of broaden it to more of a prairie perspective and look at the spread and economic costs of Fusarium, managing soil and seed-borne Fusarium, some tips and tricks on that, and then end with talking about how to optimize a foliar fungicide application and some information and some references of where to go to look for some sprayer applications, because that really is the key if you're going to put a foliar fungicide down. So from a history point of view, Fusarium, since the 1990s has cost anywhere from $50 to $300 million in losses. First confirmed in Manitoba in the early 1920s, and then in southern Alberta in the early 1980s. Shortly thereafter, a few years later in Saskatchewan, it was detected, and then a severe, serious outbreak in the early 2000s in Manitoba. And Manitoba and along the border in eastern Saskatchewan have really been dealing with this and have been living with this as wheat producers in that area. As we got into the late 2009, we started to see in southern Alberta, especially in irrigation, in Durham area or soft white wheat, starting to see the downgrade and the issues of the quality and the yield come into play. So if we look at a perspective in the last 15, 16, 17, this is 3 maps each year, percentage of samples containing Fusarium damaged kernels, so the incidence. 16 was a very wet year, and you can see right across the prairies from Manitoba, eastern side, all the way to southern Alberta and the rest of Alberta. It was very much an incidence and an issue There are still some producers that I know of in 2016's crop, especially durum, that are still trying to move that crop. So not only is it a yield and a quality, but it becomes the ability to move an infected crop like that. If you see in 2017 was a little bit on a drier year, but still in Manitoba, it's still an issue. The incidence of Fusarium has been there for in most fields for quite a while. As we look at the overall average and break it out by crop district from 2013 to 2017, we start to see along the eastern really supports that messaging. Fusarium frequency is really from along the border and then really taking hold in Manitoba. So it's really important to understand your field history as the Fusarium pathogen persists in the soil and on residues. So as Dr. Mike Harding was talking about, scouting and monitoring and record keeping, it's really important to keep track of where you've had the issues and where it's been in your fields and how to set a plan to manage it. So as we can see in this map, we've had some wet years, we've had some dry years, and we've had some normal years, and it does persist, especially in the eastern prairies, eastern side of Saskatchewan and into Manitoba. So when we look at the overall economic impact of Fusarium, the value of the grade loss is higher than the yield loss. And that's really a difference with this disease. The revenues you lose to downgrading, can vary from $35 to $100 an acre. And when you look at even the last 3 years, which 2 of these years have been relatively dry, we see that Fusarium downgrading the class from a 1 to a 2 or a 2 to a 3, a third of the time is caused by a Fusarium grading issue. So the takeaway here is really the value of grade loss is higher than the yield loss. So when we look at seed treatment recommendations and looking at your seed source, it's important to get your seed tested for the different seedling diseases. If your seed comes back and it's testing greater than 14% for Fusarium or Cochlear bolus, your seed should be discarded. And if your seed tests greater than 5% for Fusarium graminearum, it should be discarded. When you look at these levels, even if you use a premium seed treatment, it's not going to give you enough activity to manage the disease. The diseased seedlings are going to be susceptible to reduced vigor and germination, and as a result, you're going to see potentially a stand that maybe has plant reduction and or unevenness. And we'll get into trying to address how to, when you get into an uneven field or a field that's got some different variability in it at head timing when it comes to fungicide, when you're looking at using a seed that is potentially has that source of diseasing on it and it's reducing your stand, that even makes it more of a challenge come fungicide timing. So when we're looking at seed treatment recommendations, so seeds that test positive for Fusarium or Cochlear bolus may be treated with a premium seed treatment. It's important that you check your labels. So once you find out what you're dealing with in your seed, that your seed treatment will look after it. It's important that if you had no history in a field for Fusarium, it's important not to introduce it with infected seed. Try a different seed source. Do not introduce the pathogen to the soil because it can now, once it's in that soil, you're now going to be dealing with it over the history of cropping that field. So important to know what you're dealing with your seed. Treat it with a disease that with a seed treatment that covers that disease on the label, and that you take that seed sample and put it into a field. Do not put it into a field that it could be potentially introducing a pathogen for the first time. So when we talk about a premium seed treatment, new from BASF this year is Ensure Cereal FX4. It's 4 modes of action, including Xemium, and it's got an expanded disease label to go after protecting seedling Fusarium protection. It enhances the Fusarium protection because of the xemium. It gives you continuous and consistent control and movement up and down the shoot for protection both on the root side to give you increased root structure and increased shoot growth as well. So when you increase the plant biomass, you get a quality plant stand, you get more of an even plant stand, you mitigate the stresses that could come by increasing the stress management, and overall more consistent control. So when you look at using a premium seed treatment like FX4, it gives you your crop off to a good start, it allows for more even germination, and hopefully allows for a easier and better application, and starts that whole process or the whole gamut of protection against Fusarium. So when we move into timing for looking at managing for fungicide timing, one of the things when you're looking at barley, you want to apply when the heads have fully emerged within 1 or 2 days. When we're looking at wheat and other cereals, you want to apply once 75 to 100% of the main stems have emerged to when 50% of the heads are flowering. Caramba, like other, is BASF's offering for suppression and protection from Fusarium graminearum. What you're looking at from Caramba is that you want to apply it about 2 days after flowering begins, about 20% flowering. Important that you put on the fungicide, they're preventatives, and you want to put them on before the infection takes hold. So that's why it's early application. Once you've got close to 75 to 100% of the main heads have emerged from the wheat plants. So critical timing and weather. So what are when we talk, looking at the different years where we've had higher incidences of Fusarium versus lower incidences, it comes back to about a critical period coming into when the heads are emerged, and that's what kind of moisture do we have coming in about a week, 10 days before. So if we have a period of rain, and in some cases very high humidity, which is the eastern prairies deal with, where we have moisture on the plants, that's the timing when we want to look at spraying a Fusarium head product, a fungicide like Caramba. Again, we want to do that once 75% at least of the heads are emerged. The temperature-wise for infection and for the development of the inoculum, it ranges from that, it'll develop from a range of 10 to 30 degrees. Optimum is around that 25 degrees Celsius range, which for most growing areas and growing seasons, that's pretty much the average at that time of year. So as we're looking at spraying a window for Fusarium, we want to look at a couple of days. That 20% flowering seems to be the real sweet spot for applying on the head. Some of the trials that we did internally in BASF just to kind of make sure that we hit that right timing to get both the most disease reduction and get the most yield out of our fungicide. We looked at comparing to an untreated check. We looked at 3 different timings. The first timing, A on the bottom of the graph, where we look with Caramba, 50% of the main stem heads have emerged. The next timing, the B column, it's about 20% flowering, which is roughly a couple of days after that. And then a later application timing, which is about 3 days after. And sometimes growers will push off to a later application when they have more variable crop growth out there to be able to get more heads. Well, what we've seen is that if we can try and zero in on that 20% flowering timing, we get both the most reduction in disease and we get the highest yield. So this is trials where we were able to, within the BASF camp, to get the most out of our Caramba fungicide. Continuing with our trials, we've had the product, we've been testing it for well over 10 years. When we look at close to 100 trials with Caramba at that about that 20% flowering time, we see that compared to the untreated check, we're averaging about 15% yield increase over time. And majority of the time when we're looking at applications of these close to 100 trials, we see that we do get a yield bump, and by applying it at the right time, and protecting that head from infection. So I'm just going to wrap up with a couple of last slides, and this is more about application. So one of the important parts of the application technology is looking at how to apply the product. When you think about a wheat head versus a leaf when you're spraying for leaf disease versus head timing, the head is vertical and it's very hard to get both sides of the head and making sure that you get good coverage to get good protection across the whole head. So one of the things you want to look at is water volume, minimum 10 gallons, more water the better. Traveling speed normal, lower booms so that you can provide a pattern that has overlap but getting closer to the target, so maybe even down to 10, 12 inches, coarse spray nozzles, and trying to hit wide angles. From spraying tips from Sprayer 101, so if you want to take a peek online after the seminar, take a look at Google Sprayer 101 website. There's some great tips for not only spraying fungicides for Fusarium head blight, but for other applications as well. And their findings there are they talk about using twin flat fan nozzles that are angled, preferably backward pointed to help get the other side of the wheat head. So when I talked about getting both sides of the wheat head, that really helps. Using coarser spray droplets so that they maintain their integrity, they penetrate into the head, and they're able to hit the head from higher distances. And when you think about if you're a durum grower, you know you got awns out there. If you're using finer droplets, that will actually catch the droplet before it gets the head and not give you the protection you're looking for. Lowering boom below 25 inches, even down to a foot, that's where you're going to have to adjust it for your own operation. And when you're looking at the variable crop, and that's a question we get the most, how do I hit a crop that's got variable applications? Setting your application in your boom height, your water volume, using twin fan nozzles and using coarser spray droplets really do help, and higher water volumes really do help in getting your best out of your Fusarium head blight application of your fungicide. So with that, I'll turn it back over to Sean.
Hey, thanks a lot, Bruce. Great stuff. Lots of great tips in your presentation, both presentations we've had so far. Our final presenter is a grower with 35 years of experience under his belt. Maurice Van Winsberg owns and operates Van Farms. It's a 4,300-acre grain farm in southern Manitoba, where he grows hard red spring wheat, canola, peas, soybeans, and edible beans. He's always believed in the importance of finding proactive ways to approach the challenges in agriculture. Maurice, how's it going?
Good. How are you doing?
I'm doing really good. Thanks a lot for being on the webinar here. So, Maurice, tell everybody out there a little bit about your farm operation.
Well, it's basically like the introduction said. We have 4,300 acres. I farm with my son and his family, and my parents still are a little bit involved in the farm, along with my wife, Leanna. We farm 4,300 acres. It's a very good area to farm in Western Canada. The soils are very fertile, and we generally get pretty decent rains in this part of the world.
So Dr. Harding and Bruce have walked us through the life cycle and the spread of Fusarium. In your 35 years of farming experience, how long have you been dealing with Fusarium on your farm?
Yeah, I remember it very well. It was 1994. We had a lot of rain. Crop looked just beautiful, and I remember scouting the crops in the midsummer, and I was wondering, what the heck is this on our heads? And come harvest, we realized what it was. The first time we had Fusarium, it was really bad in 1994. We've been battling it ever since. Some years worse than others, but we've had some really bad years of Fusarium.
Now, a lot of growers in Manitoba, because of Fusarium, the Red River Valley has been really impacted. a lot of growers have just given up on wheat, but you still have hard red spring wheat in your rotation. So what are some of the things that you're doing to manage it?
Well, we do grow a lot of wheat. We are looking at, maybe someday down the road getting into corn and oats. But so far, we grow wheat. It's on a 2-year rotation, which isn't really the best, but it's what we do. Why we're still at that, I'm not sure. But it's for us. We are in an area that can grow good wheat yields. So we can grow wheat 80 to 90, even 100 bushels an acre in this area. And that's why we're still growing it, because obviously it's profitable for us, but we need to get those yields for wheat to be profitable.
Okay, so shed some light on it. Give us some of your secrets, your tips and tricks. How are you actually managing this disease?
Well, it's there's no real rocket science to it. Some years sometimes it's a bit of luck, but what we try to do, you want to sow thicker. Start with good seed. You want to make sure that your germination is as best as you can get it. And we'll probably seed about 140 pounds of seed an acre. So you want that wheat stand to be healthy and to come up as even as possible. The second thing we try to do, you want to have a very good fertility program. We've noticed throughout the years that if the wheat is not fertile, it seems to be more susceptible to Fusarium. The healthier the plant, the more it can fight the disease, it seems to be. So we also put on an application at flagleaf. So we will go with probably like a headline product at flag, probably at early flag. We're starting to use manipulator now at early flag with a headline. And then when we get into flowering, well, it's exactly like what Michael and Bruce said. We want to make sure that 75% of the heads are emerged, and we want to try to have about 50% flowering. And what we do is we use twin nozzles. We use Guardian Air twin nozzles. I believe they're 45 forward, 45 back. We spray at about 8 to 10 mile an hour. We go 18 U.S. gallons of water product, so we use a lot of water. And, that's what we do. Sometimes, we've had dry springs where the wheat germination is maybe not as good as we like. Well, then obviously, unfortunately, you'll have less control on your Fusarium. So those are some of the things we try to do on the farm here to, just try to do our best. I hope I answered your question.
You said you're growing hard red. Oh, sorry, go ahead. Finish up.
Well, go ahead.
I was going to say you're growing hard red spring wheat. I'm assuming you've selected hard red spring because it really does have a little bit better protection against Fusarium than, say, a durum or a soft wheat.
That too. Like, you want to make sure that it's the best variety to fight Fusarium. And a lot of times it's a trial and error period, but you'll look at the wheat, you look at your grower's guide, look at the traits of the seed, and you definitely want to get a variety that is as best as you can get to combat Fusarium. The variety combined with your Caramba is probably the best thing you can do to fight Fusarium.
Okay, if you think back to when you started to get impacted by Fusarium, you could do two things. You could roll over and just say, well, I'm going to knock cereals out of my rotation, or I can continue to, I can try to figure what the proactive things are to do to prevent the disease as much as possible. As you look at your area, what would you say a lot of people did? Did people get proactive right away, or did the disease really cause a lot of economic hardship for the first while?
The first 10 years were actually pretty tough. We had varieties that were highly susceptible. I remember we were growing domain wheat, domain hard red spring was highly susceptible to Fusarium. There wasn't a lot of corn thought of. Now we're starting to see more corn. So farmers continued to grow wheat. There was an increase in oat acres, barley. Maybe some guys tried to grow barley. But, all we tried to do was our best for those first 10 years. It was tough. I know on our farm, we we did build a cleaning plant, and we started cleaning wheat. So if we had a bad year, we were cleaning our wheat, and that was quite beneficial for us to be able to find a good market for our wheat. And we still use that cleaning plant. And in 2016, we had a very good wheat crop. The sample looked actually very good. But the problem was that all the wheat in our area, it was all over 2 parts per million dawn levels, and none of the millers wanted the wheat. So we ended up cleaning nice wheat at that time. It was funny, the wheat looked good, but it still had too high dawn levels. So we were able to clean it out over a gravity table. We remove about 5-6%, and then we're able to market it. So just an example of like how the farmers here are struggling with wheat. I think we're going to see a lot more corn going into the area in the future, and I think that'll be the thing that'll help us with that. The only thing with corn is just fantastic for being an inoculant source for the Fusarium. That's the drawback with corn.
Yeah. You sort of alluded to it there a little bit, but how has Fusarium and being impacted by the disease, how has that impacted your marketing of your wheat crop?
Well, like I said, the thing with Fusarium is if southern Manitoba has a bad Fusarium year, a lot of times in the past, we've relied on Saskatchewan, Alberta to blend our poor quality wheat off. So that is concerning for us going forward. If Alberta and Saskatchewan get bad Fusarium, we're going to have a harder time to market our wheat. Also, again, farmers have cleaned wheat to help market it, and it just makes it difficult. When everybody has downgraded due to Fusarium, then the elevator companies are scared to take it, and they're not unsure. A lot of times we've had years where it takes till maybe December till the elevator companies know what to do with it, or they got it. If it's 5% levels, let's say in Fusarium, they'll have special programs to buy the higher Fusarium wheat. So marketing is definitely a challenge. It's a real headache a lot of times, and it just comes with that problem. It's not just yield loss. It's marketing can be a real challenge when you have Fusarium damage in your wheat.
Absolutely. Yeah, absolutely. You just look at, it's not just wheat. You look at the dawn levels and the infection that happened in Ontario this year and how it wreaked havoc on the Ontario corn crop. Producers in that province can definitely agree with a lot of things that you've just said, for sure. Hey, Maurice, thanks a lot. I appreciate it.
All right, perfect.